The delivery performance domain addresses activities and functions associated with delivering the scope and quality that the project was undertaken to achieve. What are the desired outcomes here, Mr. Izgi?
Mr. Teker, effective execution of this performance domain results in the many desired outcomes, such as projects contribute to business objectives and advancement of strategy. Projects realize the outcomes they were initiated to deliver. Project benefits are realized in the time frame in which they were planned. The project team has a clear understanding of requirements. Stakeholders accept and are satisfied with project deliverables.
Okay, can you give us introductory information about this performance domain?
Projects support strategy execution and the advancement of business objectives. Project delivery focuses on meeting requirements, the scope, and quality expectations to produce the expected deliverables that will drive the intended outcomes. Projects provide business value by developing new products or services, solving problems, or fixing features that were defective or suboptimal. Projects often deliver multiple outcomes that stakeholders may value differently. For example, one group may value ease of use or the time-saving aspects of a deliverable, while another group values its economic return or market differentiation.
Can you explain to us the delivery of value?
Sure. Projects that use a development approach that supports releasing deliverables throughout the project lifecycle can start delivering value to the business, customer, or other stakeholders during the projects. Projects that deliver the bulk of their deliverable at the end of the project lifecycle generate value after the initial deployment. Business value often continues to be captured long after the initial project has ended. Frequently, longer product and program life cycles are used to measure the benefits and value contributed by earlier projects.
What can be said about the business case?
A business case document often provides the business justification and a projection of anticipated business value from a project. The format of this business case varies based on the development approach and life cycle selected. Examples include business case documents with detailed estimates of return on investment, or a lean startup canvas that describes high-level elements such as the problem, solution, revenue streams, and cost structures. These business documents demonstrate how the project outcomes align with the organization's business objectives. Project authorizing documents attempt to quantify the project's desired outcomes to allow for periodic measurement. These documents may range from detailed baseline plans or high-level roadmaps that provide an overview of the project lifecycle, major releases, key deliverables, reviews, and other top-level information. In this context, deliverable refers to the interim or final product, service, or results from a project. The deliverables enable the outcomes that the project was undertaken to create. Deliverables reflect the stakeholder requirements, scope, and quality, along with the long-term impacts to profit, people, and the planet.
Now, we have come to a new topic, which is requirements.
Yes, a requirement is a condition or capability that is necessary to be present in a product, service, or result to satisfy a business need. Requirements can be very high level, such as those found in a business case, or they can be very detailed, such as those found in acceptance criteria for a component of a system. Projects that have a well-defined scope, which is relatively stable, generally work with project stakeholders to elicit and document the requirements during upfront planning. Projects that have a high-level understanding of the requirements at the start of a project may evolve those requirements over time. Some projects discover requirements during project work.
How do we elicit requirements?
To elicit means to draw out, bring forth, or evoke. There is more to collecting requirements than interviewing or conducting focus groups. Sometimes requirements are drawn out by analyzing data, observing processes, reviewing defect logs, or other methods. Part of eliciting requirements is documenting them and gaining stakeholder agreement.
Which criteria meet the well-documented requirements?
Well-documented requirements meet the following criteria. Clear. There is only one way to interpret the requirement. Concise. The requirement is stated in as few words as possible. Verifiable. There is a way to verify that the requirement has been met. Consistent. There are no contradictory requirements. Complete. The set of requirements represents the entirety of the current project or product needs. Traceable. Each requirement can be recognized by a unique identifier.
How do the requirements evolve and how are they discovered?
On projects that do not have clearly defined requirements upfront, prototypes, demonstrations, storyboards, and mock-ups can be used to evolve the requirements. In these situations, stakeholders are more likely to take an "I'll know it when I see it" approach to developing requirements. Evolving requirements are common in projects using iterative, incremental, or adaptive development approaches. In some cases, new opportunities arise that change requirements.
How do we manage the requirements in general?
Regardless of whether requirements are documented upfront, evolve along the way, or discovered, there's a need to manage them. Ineffective requirements management can lead to rework, scope creep, customer dissatisfaction, budget overruns, schedule delay, and overall project failure. Therefore, many projects have one accountable person for requirements management. This person may serve as a business analyst, product owner, value engineer, or other title. Those individuals managing requirements may use specialized software, backlogs, index cards, traceability matrices, or some other method to ensure there is an appropriate level of requirement flexibility versus stability, and that new and changing requirements are agreed to by all relevant stakeholders.
We will come to a new topic now, which is scope definition. As requirements are identified, the scope that will meet them is defined. Scope is the sum of the products, services, and results to be provided as a project. As scope is defined, it creates the need for more requirements identification. Therefore, like requirements, scope can be well defined upfront, it can evolve over time, or it can be discovered. How do we decompose the scope, Mr. Izgi?
Scope can be elaborated using a scope statement to identify the major deliverables associated with the project and the acceptance criteria for each deliverable. Scope can also be elaborated by decomposing it into lower levels of detail using a work breakdown structure, WBS. A WBS is a hierarchical decomposition of the total scope of work to be carried out by the project team to accomplish the project objectives and create the required deliverables. Each level down in the hierarchy represents a greater level of detail of the deliverable and work required to produce it. Another way to elaborate scope is by identifying the themes of the project in an agile charter, roadmap, or as part of the product hierarchy. Themes represent large groups of customer value reflected as user stories associated by a common factor, such as functionality, data source, or security level. To accomplish themes, the project team develops epics, which are logical containers for a large user story that is too big to complete within an iteration. Epics may be decomposed into features, a set of related requirements, typically desired as a short phrase or function, which represent specific behaviors of a product. Each feature will have multiple user stories. A user story is a brief description of an outcome for a specific user, which is a promise for a conversation to clarify details. The project team defines story details at the last responsible moment to avoid wasteful planning should the scope change. The story is a clear and concise representation of a requirement written from the end user's perspective.
Can you explain to us the completion of deliverables?
Depending on the approach used, there are different ways to describe component or project completion. Acceptance or completion criteria. The criteria required to be met before the customer accepts the deliverable or before the project is considered complete are often documented in a scope statement. Technical performance measures. The technical specifications for a product may be documented in a separate specifications document, or they may be documented as an extension to the WBS. This extension, known as a WBS dictionary, elaborates the information for each deliverable or work package in the WBS. Definition of done. The definition of done is used with adaptive approaches, particularly in software development projects. It is a checklist of all the criteria required to be met so that a deliverable can be considered ready for customer use.
Our next topic is moving targets of completion.
Yes, projects that operate in uncertain and rapidly changing environments face the situation that a good enough for release or done goal may be subject to change. In markets where competitors are releasing new products frequently, the features planned for a new release may be updated. Likewise, new technology trends such as mobile devices or wearable devices might trigger a change in direction or introduce new requirements. In these environments, the definition of the project goal being delivered or done is constantly moving. Project teams track the planned rate of project goal achievement relative to the rate of progress toward completion. The longer the project takes to complete, the further the project goal of done is likely to move. This is sometimes referred to as done drift. Projects that operate in a more stable environment often face scope creep. This is when additional scope or requirements are accepted without adjusting the corresponding schedule, budget, or resource needs. To combat scope creep, project teams use a change control system where all changes are evaluated for the potential value they bring to the project and the potential resources, time, and budget needed to realize the potential value. The project team then presents the changes to the project governance body, product owner, or executive sponsor for formal approval.
Okay, our next topic is quality.
Yes, delivery is more than just scope and requirements. Scope and requirements focus on what needs to be delivered. Quality focuses on the performance levels that are required to be met. Quality requirements may be reflected in the completion criteria, definition of done, statement of work, or requirements documentation. Much of the costs associated with quality are borne by the sponsoring organization and are reflected in policies, procedures, and work processes. For example, organizational policies that govern how work is performed and procedures that prescribe work processes are often part of the organization's quality policy. The cost of overhead, training, and process audit are borne by the organization, though they are employed by the project. Inherent in projects is balancing the quality needs of the processes and products with the costs associated with meeting those needs.
What is the cost of quality, Mr. Izgi?
The cost of quality methodology is used to find the appropriate balance for investing in quality prevention and appraisal to avoid defects or product failures. This model identifies 4 categories of costs associated with quality: prevention, appraisal, internal failure, and external failure. Prevention and appraisal costs are associated with the cost of compliance to quality requirements. Internal and external failure costs are associated with the cost of non-compliance.
Let's cover them. The first one is prevention.
Prevention costs are incurred to keep defects and failures out of a product. Prevention costs avoid quality problems. They are associated with the design, implementation, and maintenance of the quality management system. They are planned and incurred before actual operation.
Can you give some examples?
Yes. Examples include product or service requirements, such as the establishment of specifications for incoming materials, processes, finished products, and services. Quality planning, such as the creation of plans for quality, reliability, operations, production, and inspection. Quality assurance, such as the creation and maintenance of the quality system. And training, such as the development, preparation, and maintenance of programs.
The second one is appraisal.
Appraisal costs are incurred to determine the degree of conformance to quality requirements. Appraisal costs are associated with measuring and monitoring activities related to quality. These costs may be associated with evaluation of purchased materials, processes, products, and service to ensure that they conform to specifications. They would include verification, such as checking incoming material, process setup, and products against agreed specifications. Quality audits, such as confirmation that the quality system is functioning correctly, and supplier rating, such as assessment and approval of suppliers of products and services.
The third one is internal failure.
Internal failure costs are associated with finding and correcting defects before the customer receives the product. These costs are incurred when the results of work fail to reach design quality standards. Examples include waste, such as performance of unnecessary work or holding enough stock to account for errors, poor organization or communication. Scrap, such as defective product or material that cannot be repaired, used, or sold. Rework or rectification, such as correction of defective material or errors. And failure analysis, such as activities required to establish the causes of internal product or service failure.
The fourth one and the last one is external failure.
External failure costs are associated with defects found after the customer has the product and with remediation. Note that to consider these failures holistically requires thinking about the project's product while it is in operation after months or years, not just at the handover date. External failure costs occur when products or services that fail to reach design quality standards are not detected until after they have reached the customer.
Okay, what kind of examples can we think of?
Examples include repairs and servicing for both returned products and those that are deployed, warranty claims such as failed products that are replaced or services that are re-performed under a guarantee, complaints for all work and costs associated with handling and servicing customers' complaints, returns for handling and investigation of rejected or recalled products, including transport costs, and reputation, where reputation and public perception can be damaged depending on the type and severity of defects.
To optimize delivered value, early inspection and review work focused on finding quality issues as soon as possible are good investments. Attempts to test quality in late in the development lifecycle are likely to fail because discovering quality issues late in development is time and cost prohibitive due to high rates of scrap and rework, along with the ripple effect to downstream outputs and stakeholders. Now we come to a new important topic, which is the cost of change.
Yes, this is an important topic. The later a defect is found, the more expensive it is to correct. This is because design and development work have typically already occurred based on the flawed component. As we see on the figure, activities are more costly to modify as the life cycle progresses, since more stakeholders are impacted. This phenomenon is characterized by the cost of change curve. To counter the impacts of the cost of change curve, project teams design project processes to build in quality. This approach can include quality analysts working with designers and engineers to understand and determine how best to achieve quality during each step in the project lifecycle. Being proactive about quality work helps avoid the high cost of change associated with fixing quality issues discovered later in the life cycle. It is quicker and more cost-effective to fix a design problem between two engineers than a component problem affecting hundreds of units, or to recall a product impacting thousands of customers.
Okay, our last topic is suboptimal outcomes. What are suboptimal outcomes, Mr. Izgi?
All projects attempt to deliver outcomes, though some may fail to do so or may produce suboptimal outcomes. The potential for suboptimal outcomes exists in every project. In the case of a fully experimental project, the organization is attempting to achieve a breakthrough, such as the creation of a completely new technology, for example. This requires deliberate investment in an uncertain outcome. Companies that produce new medicines or compounds may experience several failures before finding a successful formula. Some projects may fail to deliver outcomes because the market opportunity has passed, or competitors were first to market with their offering. Effective project management can minimize negative outcomes, but such possibilities are part of the uncertainty of attempting to produce a unique deliverable.